let us solve one question on AC power and wattmeter. Here is a circuit where we have a resistor, an inductor and a capacitor connected in a way, and a supply voltage is connected which has 60 volt RMS voltage across it, and one wattmeter is connected here. We have to find the reading of this wattmeter. You may solve this question possibly in different ways, but if you carefully look at the circuit, then it may become easier to solve this question easily. Notice that we can consider this resistor, inductor and the capacitor together as one load, and this source voltage is applied across the load, and here we have a wattmeter. Now notice that the pressure coil, voltage coil of this wattmeter is measuring the voltage or the potential of the left side of the load with respect to the right side, and this current coil will measure a current that is flowing from plus to minus end of this current coil. That means a current that flows in this way. Okay, so that current will flow like this, and then like this and like this. So the wattmeter is measuring the time average of the product of the voltage of the left side of the load with respect to the right side multiplied by the current that is flowing from right to left side of the load. Okay, so let me write. So the wattmeter reading will be negative of the power consumed by this load. So that will be equal to minus power consumed by the load. Now, how much is the power consumed by this load? Notice this capacitor will not consume any power, neither the inductor can consume any power on an average. So the power consumed by the load is same as the power consumed by this resistor. And how much is that? So this will be equal to minus of 5 ohm multiplied by the square of the current through the resistor. So if I call that current as IR, okay, so IR square multiplied by 5 ohm, that will be the power consumed by this load. Now this will be equal to minus 5 into how much is IR, current through the resistor. The voltage from here to here is 60 volt RMS, so 60 divided by 5 plus J12, 5 plus J12, okay, that is and if we take the square of the magnitude of this, that will give, this quantity will give the power consumed by the load in watt. So this will be equal to minus 5 into 60 square divided by the denominator will be 5 square plus 12 square is 13 square, and this will be approximately equal to 106.5 watt with a minus sign. Okay, so the answer will be minus 106.5 watt.